Hello, class. So congratulations on making it to the end of Calculus 3. So you finished book 3.5. Really fun to look at those assignments. And I want to spend a good bit today talking about your final exam. So I will briefly just do some shout outs for the activities and calculations for chapter 3 of book 3.5. It's really neat to see some folks did. It seemed like the vector fields, you have a really good understanding of them. Many people did the scavenger hunt, did a really nice job just collecting vector fields outside. Some of those I remember were Grace and Phoebe. Phoebe talked about birds flying against the wind would make negative work. Grace talked about these things called, I didn't realize, the Jenny seeds. So those are like the seeds, and then the almost looks like a helicopter wing, and those spinning and the path that they would take. Some really neat vector field collections from Kendra, Kyla, James, Madeline, and Gavin. I think Gavin's in particular was one. He really had a lot of aerodynamics of vehicles, so the vector field that goes around that. Madeline had an interesting one on just apps on her phone that were like weather apps with winds or wave directions. Let's see. Oh, interesting to see the sinks and toilets and shots that Kendra and Haley had of those, or movies. I think Madeline, Gavin, and Calvin all made really cool new movies that you could see totally what's happening with that vector field. Nice visualizations. Calculations as usual, some really good ones to look at. Noah, James, Madeline, Grace. So those are good people too, if you're studying for the final exam, to take a look at their work, ask them if they'd shoot some things over for you. Okay, but let's then share the screen and spend the rest of this time, because I want to make this efficient. I know it's coming to the end of the semester. You guys are getting busy with lots of things in this class, and all your classes in general. And so the thing I want to focus on, we'll go to your Oaks page. Our final exam. So first thing was, thanks to, I think it was Noah and Trip notified me that the date was wrong on the final exam. So we're going to look in two things here. We're going to look at this module 8 final review, and then we'll go to your final exam. But let's just first, for now, it's not accessible to you guys, but there's two things in there: your final exam, and then the work that you're going to put in there. And the window that I had was wrong. So again, thanks to Noah and Trip for notifying me. We are take this on a window. So this window starts not this Friday, but next Friday. So you have a good week and a half to study and plan it out with the other classes. So that Friday morning at 1 a.m. and then it closes Sunday evening at 11:59. So nice long window there. It's a 3-hour block that you're going to set aside to work on this exam. It's done through Oaks like our quizzes have been, but you're going to have to show your work and submit that. And when you pick your 3-hour window, maybe you decide you get off of work, you're going to eat some lunch, and then you're going to take it at 2 o'clock on Saturday. So you'd come in here and start this. Oaks will start its timer at 2 o'clock. At 5 o'clock, it'll shut you out and you won't be able to submit any more there, but you will be able to submit your work, and you have to submit your work within 10 minutes. So what you've done here on Oaks, it's multiple choice, you're collecting things, but you have to share your work for every problem. And so you're going to write them down in order on any paper, usual deal, take pictures, upload it. And then you have to do that by 5:10. So you have 10 minutes to get that in or thereafter. Okay, so that's the process for how we're going to take and submit our exam. But let's talk about how we're going to study and prepare. And the good news is you've done most of that already. So I've had students in semesters past talk about how surprised they were when they sat down to study, how much they knew and how efficient their studying was because of this deconstruct format, that things were very personalized and internalized already at this point. So here's your final review. We've mentioned this before at midterm, but there's two places then you can go. You can practice problems here. So as usual, the books and everything we've done this semester, we have this emphasis on concepts and on calculations. And so the concepts, you have plenty of practice. Our old quizzes in Oaks, every chapter at the end of your journals, every chapter has plenty of concept reviews, so go over those. That's a good place to prepare. Your final exam will be probably 45 to 55 questions, so roughly about 50 questions, multiple choice, half of those will be concepts, so they should be done rather quickly. And that's the first half of the exam in OAKS. So if in those first half of the questions, you're realizing maybe you're doing some calculations, you're probably thinking about the problem wrong because it's meant to be a concept question. For those, not much to show work, right? So those are our concept ones. Do you know your vocabulary? Do you know your key terms? Do you know your formulas and theorems? Do you know why we're doing these calculations? So again, good place to practice there is going through every chapter. So there's 7 chapters we've covered between the 2 books and looking at those concept questions. And then after you finish that first half on OAKS, you should go through that rather quickly. I'm going to say maybe 30 at the most 45 minutes. That saves you a good 2.5 hours to finish the calculations. And there'll be 20 to 25 calculation questions, cumulative, covering all the topics that we've had, and good places to look for those. Well, first thing, go through the practice here, the midterm calculation and the final calculation practice. So we can click on one of those, and there's answers provided by previous students that show their steps. But these are usual things like, hey, find the traces of this particular function, describe the surface, graph 1, a couple examples there, computing gradients. So these are our computations, right? But you have to show your work for these. These problems will not be graded if there's no work, because you've learned some really nice tech tools that we could just type some of this in. But if you don't show your thought process and your work, 0 on that problem. So just want to emphasize that. And there are some problems though, where it will say, let's see, let me give an example here. Because there were a couple questions like, hey, I'm using tech tools, like, okay, arc-length ones. Most arc-length problems are nasty. We've talked about that before. Lots of curvature ones are nasty. It's getting some of these vectors nasty. So either they'll be very simple that you can do by hand, or it might say, set up the integration to find the arc length. And so you're going to, that's part of your work. You have to choose which is the right integral out of the multiple choice, and then set it up on your paper by hand, show your work, and then it'll prompt you and say, and then use the tech tool to complete the integration. And so I'm allowing you to use it. I want you to use it on those particular ones, but all the other ones you have to, again, show your work. Okay. And let's see what else. So concept and calculation, we've got 3 hours in this window from Friday, December 10th, 1 a.m. to Sunday, December 12th, 11:59 p.m. The questions are randomized for different students and randomized by the answer key problems. You're doing it individually. This is your own work. Again, you have to submit your work, but you also have to submit a study guide, and that could be up to 2 pages. So I want you to make something beforehand that's going to help you be efficient. Like, so we're not flipping through the journals to find the formula for the surface area, right? So you already have that on your study guide. I encourage you to work with classmates to make those study guides. Maybe Grace has already made hers and Jake's working on his. That's fine, like share those and then maybe merge them and think, did I cover everything? You can put formulas on there, you can put definitions, you can put small examples. So 2 pages to make a study guide. Have that ready when you sit down to do your window to take your final. I want you to use that, again, to make it efficient and make you less stressed about this. So do your prep to make a study guide as you're studying, and then submit that with your work. So again, when you submit your work, all those calculation problems numbered clearly. Make sure you also have your work and your study guide. Okay. What else do I need to say? Okay, so then you'll go through these. This is a good thing to sit down this next week and practice. Again, practice on your own, practice if you want to show and get a whiteboard with your teammates in the library. This is a good thing. I can guarantee that there will be, like, you can think about the highlights of the problems that will be on there. I can tell you there will be this one right here, find the point on the plane, find the equation of the plane, given certain parameters, find the point on the plane closest to that. That makes it an optimization. I promise you there'll be something like that where you can solve it with the Lagrange multiplier method. Make sure you know that. Let's see. Yeah, find the plane through these points. There will be an arc length and a curvature, either easy to do by hand or just set it up and model it with a tech tool. Oh yeah, definitely gonna have stuff on gradient fields and things we just did in this last chapter. So you see this has hit several times, right? The point on the plane using Lagrange multipliers to find the plane somewhere else. So those are kind of hints of things that are absolutely definitely going to be there. There will be, just think for each chapter, like if I had to put, as you go through them, if she's going to put 1 or 2 questions from this chapter, what would they be? And again, this is a really good indicator here of the types of questions that you're going to see. You absolutely have partial derivatives, you absolutely have gradients, absolutely have the d-test stuff. Okay, and then let's go back to that same module. So as you work those out, then you can come back and check. A previous semester really detailed student. Rian put all the work in there, but there's some names you know from this semester if you want to work them out. Text Noah or Madeline or James, all those names we keep hearing on their calculation work. Ask them if they'd be willing to send theirs over. Hey, did you do the practice final? Can I see what you did? Okay, and this is again detailed work from Rian from the previous semester. Okay, and then last thing, midterm. So you'll see that, but that's only halfway up through the class, but that's more practice problems in that first half. So that should fill up your time for studying, making your study guide, going through the end of chapter concept reviews, going through these calculation practice problems here. And doing those things with partners and teammates, always helpful. Also, I've noticed, thank you to Madeline for another typo you found in the book. I appreciate those. Any of those you find. One more reminder about surveys, course evaluations at the end of the semester for every class, but please do them for mine. Take the time now, sit down, it only takes 5 or 10 minutes. Anything you write is helpful for all your classes, but in particular, I'm trying to make this class better and better each semester, and your feedback is essential to doing that. So thank you for the folks who have already done it, and please everyone do it. I want you to be heard. I want you to tell me what I can work on, what I should keep on doing. All right, let's see what else in the notes. All right, well, I think that's all that I've got to cover. So this was our last weekly update. You can do this. You can do a great job. And again, I think you'll find as you're studying that you've had fun this semester and internalized a lot of these concepts. So just manage your time to make that study guide, go over these practice problems, and you'll be ready. Oh, I guess I should say one more warning is because these semesters have been weird with COVID, there's a lot of people in the college trying to find cheaters. I mean, that's what they spend. I hate to say it, but so many of my colleagues, that's what they're spending so much of their energy on. So please don't be tempted to do that. And for mine, again, there's places where you can use tech tools, but you've got to show your work or it's not going to be rated. And this gets passed on to beyond me. It goes to another calculus review board, and beyond that, it can go to the overall math. So, and other departments are doing this. So just don't be tempted. It's not worth it. You've put in the work, or if you haven't, you're willing to accept those consequences. Okay. But again, most of you have put in excellent work this semester. I expect great things. And I look forward to seeing what you've done with the finalists. It's your chance to show off all that you've done. All right. Again, thank you for a wonderful semester. Last little bit, keep pushing, and you can make it.